Okay, so solving by completing the square. So let's say we have x squared plus 2x minus 6 equals 0. And again, when you're just solving a quadratic equation, when you're not told how to solve it, when the just question is solve this equation, the first urge should always be to factor it. That's the first thing you want to try. So if you try to factor this one, it won't work, right? It doesn't work. So when it doesn't work, you really have two choices, either completing the square or quadratic formula. Given those choices, can use quadratic formula, it's faster. But completing the square is still a valid technique. You'll see it in college algebra in other places, not just for solving equations. So the way we do that, we don't care about this constant. We want to make our equation to look like extracting the square root, meaning all the variables on one side, constant on the other side. So we don't like that 6. We're going to add 6 to both sides. So we have x squared plus 2x equals 6. Then we're going to complete the square. We're going to add that magic number. Now this rule tells me right here that in order to find that magic number, I need to take the coefficient in front of x, half it, and square it. Okay? So the coefficient in front of x is 2, so I'm going to take 2, divide that by 2, and square that. So I'm really adding 1, right? But if I add 1 to the left side, I have to add 1 to the right side as well to keep equation balanced. Yeah, well, because again, if I do something to one side, I have to do the same thing to the other side. So the other side becomes 7, the right side, while the left side now is a perfect square trinomial. It factors using the square root of a sum formula into x plus 1 quantity squared. And that was the whole idea why we're adding that special number, so it makes that perfect square trinomial. This whole thing is x squared. You know, that's your a squared plus 2ab plus b squared formula. And it factors into a plus b. So now we are in extracting the square root form. So we can take the square root of both sides. And this is the case where I do need plus or minus, because that's an even radical. And then to solve for x, you subtract 1 from both sides. X equals -1 plus or minus the square root of 7. So there are two solutions. Whatever they are, you leave them like that. One is -1 plus root 7, and the other one is -1 minus root 7. Two separate solutions. Is that okay? Okay, let's try another one. X squared minus 6x minus 11 equals 0. What should I do first? What was that? That's right. See if you can factor. Can we factor? No. So, all right, so let's do this still by completing the square for the sake of practice. So what should I do then? All right, add 11, get rid of that constant. So now we have x squared minus 6x equals 11. So now we're going to complete the square by adding that special fancy little number. What would that number be? 9. And again, the way we get 9, we half 6, and then we square it. So we're adding 9 to both sides. So the left side is perfect square, x minus 3 squared, while the right side is 20. So then again, we can extract the square root. Okay, when you have all your variables inside that square, you can go ahead and take square root of both sides. Just remember plus or minus when you do the square root. If we did the cube root, you don't need plus or minus. You only need plus or minus for even powers. Is that okay? Yeah, we're going to add 3. We can simplify 20. 20 is 4 times 5. So we can do square root of 4. So that becomes x equals 3 plus or minus 2 square roots of 5. So these are the two answers. Is that okay? Okay. Now, the only way I can make these problems harder, well, okay, let me make this one not all that hard, just a little harder. Let's put x squared plus 3x plus 1 equals 0. So again, you're going to try to factor, it doesn't work. So we're going to start solving it by, subtracting 1 from both sides. So that gives me x squared plus 3x equals negative 1. Okay? And again, we did examples like this on Friday, but what do I need to add to complete the square? What? 9/4. You still follow the same procedure. You're taking your middle number, you half it, and you square it. So you get a fraction. Oh well, so we're going to add 9/4 to both sides. So again, the left side factors into a perfect square x plus 3/2 squared. The number goes inside the parentheses before you square it. So 3/2. The d over 2 part ends up inside the parenthesis. While the other side, we're going to turn -1 into -4 over -4. I'm sorry, -4 over 4 to have the common denominator. So when you add this two, you'll have 5/4. Right? -1 plus 9/4 is 5/4. So we have fractions, not that big of a deal. Again, we can kill the power 2 by taking the square root of both sides. X plus 3/2 equals plus or minus the square root of 5/4. And we can take the square root of 4. So denominator is just 2. So really what I have is plus or minus square root of 5 all over 2. Because I can take the square root of 4. Is that okay? And then finally subtract 3/2. X equals -3/2 plus or minus the square root of 5 over 2. They have the same denominator. I can push them together. -3 plus or minus square root of 5 all over 2. So these are the two answers. Is that okay? So again, this is your completing the square. Get rid of the constant, divide the middle by 2, square that, and proceed with extracting the square root. But all these problems did not have a coefficient in front of the square term. Okay? Now if I put a coefficient in front of the square, for example, 2x squared plus 8x plus 3 equals 0. So again, as before, we don't care about this constant, the 3. We're going to kick the 3 out. This leaves me with 2x squared plus 8x equals -3. Now, the technique for completing the square, this little trick, says that I do not have anything in front of the x squared. There's no constant, right? That's when it works. If there's no constant in front of the x squared, we're going to take that middle constant, half and square it. Well, I do have a constant in front of the x squared. Is there a way to get rid of it? Yeah, divide everything by whatever that number is. So divide both sides by 2. Okay? So 2 divides both terms on the left, gives you x squared plus 4x, while the other side is negative 3 halves. So that's an extra step we have to do. The rest will be the same. Add the missing numbers, so we're going to take 4, we're going to half it, and we're going to square it. So 4 over 2 is 2, 2 squared is 4, so we're adding 4 to both sides. Okay. Now I have to do some fraction addition here. So it's same as negative 3 halves plus common denominator is 2, so that's 8 halves, right? 4 turns into 8 halves. And then you're just adding them. You're getting another, looks like 5 over 2, so 5 halves. So the left side is a perfect square, x plus 2 squared. The right side is 5 halves. Is that okay? And go ahead, take the square root. You do need plus or minus because of the even radical. Now, this thing on the right, the square root of 5 halves, it is one of those examples when we actually have a radical in the denominator, right? I do have a square root of 2 in the denominator. I can think of the right-hand side as square root of 5 over the square root of 2. Doesn't simplify any further. This is something you know is impolite to have, right? We don't like having radicals in the denominator, and there is no way to get rid of it but to rationalize that denominator. And that's what we were doing last week. Remember how to rationalize? You have to multiply by square root of 2 over square root of 2. We don't like seeing radicals in the denominators. So that actually gives me plus or minus the square root of 10 over 2. You multiply 5 and 2 in the numerator, and the two radicals kind of cancel each other in the denominator. And then to solve for x, just subtract 2. So it's negative 2 plus or minus square root of 10 over 2. And you can leave your answer like that. That's fine. Is that okay? Let's try this. 3x squared minus 4x minus 5 equals 0. And as I'm solving this equation by completing the square, I'm going to outline the steps that we use. So over here I'm going to have the steps. So what's the first thing I'm going to have to do? Yes, if you can factor, good. And the thing is, even if you can factor that, and it takes you more than 12 seconds to factor, because sometimes it takes longer to factor than using some of the alternative techniques. So it's okay to still use, whatever. But yeah, so if you try to factor, we'll multiply 3 and negative 5, that's negative 15. So we need numbers that multiply to negative 15 and add to negative 4, so that doesn't work, okay? So if we proceed with completing the square, what's the first thing we're going to have to do? at 5. So that's the first step. Move the constant term to the other side. So we have 3x squared minus 4x equals 5. Now what? Divide by 3. So the second step would be to divide both sides by the coefficient in front of x squared. So in this case it's 3, so divide both sides by 3. So this gives me x squared minus 4/3 x equals 5/3. And then we're going to complete the square, right? So that's the third step. Complete the square by adding the missing term. So how do I find the missing term again? Yeah, take the 4/3 divided by 2 and square that, right? So, and we talked about this on Friday, I think, that we actually had 4/3. Half of 4/3 is 2/3, right? So this is 2/3 squared. So we're adding 4/9 to both sides. That's that missing term. So this gives me x minus 2/3 on the right. I'm sorry, on the left. On the right, I need to find the common denominator, so I'll have to multiply 5/3 by 3 over 3. So that's 15/9. So I'll get 19/9. Maybe. Well, what's up? On which part? So again, so that d halves, so whatever you're dividing by 2, that what ends up inside the parentheses before you square it. So that number here is 2/3, right? That's why I got 4/9. So 2/3 ends up in there. So this number, before you square it, goes in the parentheses every time, right? I mean, look at the previous example. You know, this was 2 squared, right? And 2 goes in the parentheses. And in the previous example, if I go back, yeah, this is 3 squared. And 3 goes in the parentheses. So before you, yeah, so it's okay. Fractions are good for us. They're like green vegetables. We all hate them, but they're good for you. Right? These are your leafy greens. Oh, this is, I just added 5/3 plus 4/9. I had to do the common denominator. So when we got our square completed, then we're just going to square root both sides. So we're going to proceed with extracting the square root. So we're going to take the square root of both sides, gives me x minus 2/3 equals plus or minus the square root of 19/9. And again, 9 in the denominator, that's a friendly number. I can take the square root of that. That becomes plus or minus square root of 19 all over 3. And then just add 2/3. It's going to play nicely. with that denominator. Nick? Which part? Well, oh, you mean here? Well, I just took the square root of 9 to get 3. That's it. You good? Okay. Now again, no matter how much fun we're having with completing the square, when given options, when you're told, here's an equation, solve it by whatever means, you probably don't want to go through all that. You'll just use the quadratic formula. Again, the reason why I was spending so much time on this, it will come back. This is a very important technique of finding that missing piece and turning all your variables inside the square. Especially you're going to see it in college algebra in 3 or 4 different spots. Okay? What? Well, it's good for you. You know, this is okay. Now, oh yeah, that's besides anything that goes on here. It's just going to suck big time. You're going to look back at the old 5 days. All right, so quad formula. So again, somebody was supposed to sing a song, right? She's not here. It's not here. There was an extra credit available for singing quadratic formula song. But let's derive it. That's what we introduced that formula on Friday, and we used it a few times. We didn't derive it. Now, you don't need to write the derivation down, but you're going to help me. I'm going to start with my standard quadratic equation. And now you're going to help me to complete the square. I want to solve that general equation by completing the square. So you have the steps, right? You have those 4 steps in your notes, the ones there on the right. So just tell me what to do first. What does the first step tell us to do when you complete the square? Yeah, so get rid of that constant. So subtract c from both sides. So that's ax squared plus bx equals negative c. What is the second step? Divide both sides by a. So divide by the coefficient in front of the x squared. So divide both sides by a. So that was the second step. So when you divide by a, you'll get x squared plus b over a equals negative c over a. I'm missing an x. There's an x here. Is that all right? Yeah. You don't need to write this down. Help me. That's what I said. I can prove it. I have a way to prove what I said and didn't say. But help me. Yeah, keep writing. This is a fun little proof. All right, so we got get rid of all the constants. Now we're going to complete the square. The way we complete the square, we take the coefficient in front of the x, b over a. We're going to divide it by 2, and we're going to square it, right? That's the concept. So if you divide a fraction by 2, you just double the denominator. That becomes b over 2a, right? It's 1/2. 2 goes in the denominator squared. So this is what we're going to add to both sides, right? That's really plus b squared over 4a squared plus b squared over 4a squared, if I square that. Right? What do you mean sure? You know, b over 2a, quantity squared, you square the top, you square the bottom. That's what you add to both sides. The left-hand side now is a perfect square, so I don't really need to think a whole lot about that. It's just x. It's just x plus the expression before it got squared plus b over 2a quantity squared, right? That's how we do that, right? That thing goes in the parentheses. So whatever this expression was before it got squared, it went there. On the other side, I have to add these two rational expressions. So one has a in the denominator, the other one has 4a squared in the denominator. What is the least common denominator for these two guys? Right. Good. 4a squared. So that means I have to multiply the first one by 4a over 4a, right, to get 4a squared. So that means what I have now is b squared minus 4ac over 4a squared, right? So already start to resemble the quadratic formula somewhat, right? So this is where we're at. B squared minus 4ac all over 4a squared. Now take the square root. X plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared, right? I can take the square root of 4a squared. I can take the square root of that denominator, just 2a, right? We don't need to worry about absolute values there because of the plus or minus is already part of it. So took the square root of the denominator, just got 2a. And finally subtract b over 2a already have the same denominator, so I can push them together. So this is the quadratic formula. It completes the square in one step. It has all the steps in there already. So yeah, you do need to know this formula. There's no way, unless you want to rederive it every time. So just a few examples using the quadratic formula. This is something we can solve by factoring, by the way. This is a factorable trinomial. You're not going to have any problems factoring, right? But I just want to do this by quadratic formula to show you still get the same answers. But if we were to solve this by factoring, this is x plus 1, x plus 8 equals 0, right? That's what that factors to. Then we're going to set each factor to 0 and then solve. So x equals -1, x equals -8. And nothing beats solving by factoring. That's the easiest thing. Okay? Now, just to practice quadratic formula on this, we're still going to end up with the same answers. -1, -8. In order to use the quadratic formula, I need to identify the values for a, b, and c. And a, b, and c are the coefficients. So a is 1 right now, b is 9, and c is 8 in this example. Right? A equals 1, b equals 9, c equals 8. So we're going to plug these numbers into our formula. So x equals -b, so -9, plus or minus the square root of b squared, so 9 squared, minus 4 times a times c, all over 2a. If I plug these values into that formula. So this is negative 9 plus or minus the square root of 81 minus 32 over 2, which is negative 9 plus or minus the square root of 49 over 2. And the square root of 49 is 7, so that's negative 9 plus or minus 7 over 2. Okay? So this means two things. There are two solutions here. Negative 9 minus 7 over 2, and negative 9 plus 7 over 2. So I can compute both of them. This is negative 16 over 2, which is negative 8. This is negative 2 over 2, which is negative 1. So we still get those same answers. Of course, it's a lot longer to use the quadratic formula in this example. You would use factoring in this case. But just to demonstrate how this formula works. Every time you get rational answers, meaning you get to compute the square root, that means your equation is factorable. When your answer ends up with square roots, that means it's not factorable. Is that all right? I want to do another one that's factorable. Six x squared plus 23x plus 20 equals 0. So even if I ask you to solve this by factoring, it will take you now longer to factor this than use the quadratic formula. Because, right, you don't never like this types of factoring. You need two numbers that multiply to 120 and add to 23, right? That's what you need. Remember, you multiply first and the last. That's the product. Why so surprised? Right, the AC method, you multiply 6 and 20. That's 120, right? So that's the product, and the sum is 23. So it's going to take us a while. I mean, it's doable. Or just use the quadratic formula. So the quadratic formula tells me to go negative b, so negative 23, plus or minus 23 squared minus 4 times a times c over 2a. So a is 6, b is 23, c is 20. So it's negative 23 plus or minus, what is it, 529? 23 squared? Who's ahead of me? 529? Oh. 480? 480. So another 49. That's good. So negative 23 plus or minus square root of 49 over 12. So again, every time you end up with a perfect square under that square root, that means the equation was factorable. Only when the answer stays irrational, that's when equations are not factorable. So this is negative 23 plus or minus 7 over 12. So again, these are two solutions. Negative 23 minus 7 over 12, and negative 23 plus 7 over 12. I can compute both of them. Negative 30 over 12. I can reduce this. Negative 5/3. And this one is, what is it? Negative 16 over 12. So that's negative 3 halves. Is that right? No. What? 4/3. Yeah, what am I doing? 4/3. This is 5 halves. Yeah, there we go. I'm sorry. I'm bad with fractions, apparently. The first one is negative 5 halves. Here we go. Very good question. You always get 2 answers when you apply a formula. We'll get to that. Well, except, right. We get at most 2 answers. You don't get more than 2 when you're dealing with quadratic equations. But you can get 1 answer. You can get no answers. Okay? But just to, yeah, but I'll show you examples when we have those scenarios. Yeah, we'll get to that. But yeah, most of the time you get 2. So here's an example. We did this problem by completing the square. We did that one today already. And we got -1 plus or minus root 7. That was the answer. It's in your notes already. Just to show you how to do the same thing with the quadratic formula, again, we're going negative b, so it's -2, plus or minus the square root b squared minus 4 times a times c. And what's your signs? Be very careful with the signs. Over 2a. So this is -2 plus or minus the square root of 4 plus 24 over 2, and 4 plus 24 is 28. What? Oh, okay, yeah. So watch out for all the signs. Can I simplify this? Square root of 28, can it be reduced somehow? 28? Not a perfect square, but can you break it down into a product? Perfect square and something else? 28 is what? 4 and 7, right. 28 is 4 times 7. So I can take the square root of 4, that becomes -2 plus or minus 2 square roots of 7 over 2. And again, we did that on Friday. I can divide everything by 2 in the denominator. So -2 divided by 2 is -1, plus or minus 2 in front of the square root cancels. So we still get the same answer as we got by completing the square. What was that? Yeah, well, I just divided all 2's by 2, so. Here's another one we just solved by completing the square. And it's still going to try to get the same answer. No, we still got 2 answers. That's 2, right? Plus or minus. So those are 2 separate answers. Now again, we did that one by completing the square. It's in your notes. We got some sort of an answer. Now if I apply the quadratic formula and really watch out for the signs, it's negative b. b is -4 right now. So it's negative of -4, which will eventually make it a positive 4, plus or minus the square root of -4 squared minus 4 times a times c all over 2a. So negative and a negative makes it a positive 4, plus or minus the square root of 16, and the other one is 60, plus 60 over 6. Right? So this is 4 plus or minus the square root of 76 over 6. right? And 76 is 4 times 19. So I can take square root of 4. 4 plus or minus 2 square roots of 19 over 6. So 4, 2, and 6, these three numbers, they're all multiples of 2, so I can reduce everything by 2. Right? Technically, I factor the 2 out over 6, and then we reduce it, so it becomes 3. That's the proper way of doing that. But really, you're just dividing every term by 2. So the answer is 2 plus or minus square root of 19 over 3. And that's exactly what we got by completing the square. With completing the square, we didn't have to reduce. It all kind of reduced on the way. But if I rewind it, right, this is the last one we did. Yeah, 2 plus or minus root 19 over 3. So same exact solution. So still, that's two answers. 2 plus root 19 over 3, that's something. 2 minus root 19 over 3, that's something. Okay? So if you ask to give the answer to whatever decimals, you have to plug it in. On the exams, I'll never ask you to, I don't care what that is. Those are the answers. Okay, it's harder for me to check your work if I ask you for, decimals, because that means I have to plug that in the calculator as well. Okay, so let's consider this example. And again, solve it by quadratic formula. 9x squared minus 30x plus 25 equals 0. So using the quadratic formula, negative b, so it's negative of negative 30, plus or minus the square root of negative 30 squared minus 4 times a times c all over 2a. Right? So that's 30 plus or minus the square root. Negative 30 squared is positive 900 minus 4 times 25 is 100. 100 times 9 is 900. So it's 900 minus 900 over 18. Is that okay? 900 minus 900 is a 0, right? That's 0. And the square root of 0 is also 0. So all we have left is 30 over 18. That reduces to 5/3. So one answer, right? We only got one answer. So that can happen. Now, the reason for that, if I were to ask you to solve this by factoring, you might notice how 9x squared is a perfect square, 25 is a perfect square. So you actually have a perfect square trinomial. If you factor that problem, it gives you that. So the only way this equals 0 is when 3x minus 5 equals 0. 3x minus 5 equals 0 gives you 5/3. Right? But every time you get a 0 under the square root, you're going to get one solution, because you don't have that plus or minus. Plus or minus gives you two solutions. So if there's no plus or minus part, you get one solution. Is that okay? Nikki? Am I losing you? No. Okay. Is that all right? So one solution. Here's another example, totally random. X squared plus x plus 3 equals 0. So again, if I try to solve that, x equals negative 1, right, negative b, plus or minus b squared minus 4ac all over 2a. right? So that's 1 minus 12. So it's negative 1 plus or minus square root of negative 11 over 2. So we're getting negative under the square root. And we don't know how to do that yet, right? All we know that it's not a real number. There's no real number squared that equals negative 11. So I can stop right here and say no real solutions. So no solutions. Okay, so it's all about what happens under the square root. If you have a positive under the square root, you're going to get 2 solutions. If you have 0 under the square root, you're going to get 1 solution. And if you have a negative under the square root, you're going to get no real solution. Actually, we have a special name for that expression under the square root, the b squared minus 4ac. We'll call it the discriminant. So again, basically what happens if d is positive, then there are 2 real solutions. If d equals 0, then there's 1 real solution. And if d is negative, there are no real solutions. How's that? So we can quickly, I can write an equation. I have a silly example here. Let's say, basically all I have to do is to determine the number of real solutions. And the problem is, let's say, 2x squared plus 11x minus 3 equals 0. We're not asked to solve this, just to determine the number of solutions. And again, it's all about the sign of the discriminant. So the d is b squared minus 4 times a times c. b squared minus 4ac. I mean, that's a positive number, right? 2 negatives make it a positive, so I don't need to go any further. It's greater than 0, so therefore there are 2 real solutions. You don't need to know the actual number, all you need is the sign. Okay? Or if I give you something like x squared minus pi x, you know, whatever pi is, plus 4 equals 0. Well, this is an equation, right? Pi is a real number, why not? Again, the question is not to solve this, but to tell me how many real solutions we have. So you'll compute the discriminant. So it's b squared minus 4ac, right? So it's pi squared minus 16. Yeah, that's a negative number, right? Since pi is less than 3, then pi squared is less than 4 squared. So that's negative. So no real solutions. Yeah, and then you can quickly do that. Okay, well, let's play with this. You should be able to do most of it.